Throughout modern history, there have been visionaries who dared to dream beyond the boundaries of conventional science. Inventors who sought to unlock the mysteries of alternative propulsion, anti-gravitics, and the enigma of over-unity energy. Yet, their stories remain shrouded in shadow. Many of these pioneers, their voices silenced, their visions extinguished. Some vanished into obscurity, while others paid the ultimate price. Suppression, it seems, has been a constant companion to innovation. But recently, there's been a glimmer of hope. A new generation of self-taught, open-minded, and independent scientists has emerged. A collective effort to combat the forces that seek to keep humanity in the dark. People like Marco Rodin, whose rediscovery of vortex-based mathematics is nothing short of mind-bending. They've pushed the boundaries of mathematical understanding, opening doors to a new realm of possibilities by describing numbers as physical stationary interstitiary vectors in space-time whose values don't change. Unlike traditional mathematics, where numbers change while functions remain constant, this paradigm shift recognizes that in reality, functions themselves can represent the changing variables, opening doors to a new understanding of mathematical relationships. And then there's Malcolm Bendall, a man with a vision that defies convention. He introduced the plasmoid unified model, a concept that calculates the resonant frequencies of everything from the elements to colors, shapes, and even polarized cardinal directions. But Bendall didn't stop at theory. He applied his unified field theory to a revolutionary concept, converting mass into clean energy. His ingenious design mimics nature's use of plasma, producing colossal amounts of pristine energy. Bendall's vision goes beyond energy. It's about reshaping our understanding of the world and harnessing the very forces of nature to propel us into a new era. As Tesla was once accredited as saying, "Throughout space there is energy. Is this energy static or kinetic? If static, our hopes are in vain. If kinetic, and this we know it is for certain, then it's a mere question of time when men will succeed in attaching their machinery to the very wheelwork of nature." In the shadows of suppressed technology, these visionaries are opening doors to a brighter, more sustainable future. The plasmoid engine, a symbol of hope, innovation, and the relentless pursuit of the unknown. Join us as we delve deeper into the mysteries of plasmoids and the brave souls who dare to challenge the status quo. Here on Divine Science. Stay tuned for our brand new show. For more videos on consciousness, zero-point energy, and other forms of forbidden knowledge, like and subscribe to my YouTube and TikTok channels. What are you waiting for? Take the red pill and arm yourself with forbidden knowledge. Subscribe today.
anxious or excited. High dosage administration can cause adverse reactions. This is a normal response.
Its highlights have been compressed on this recording to make their own disquieting points.
Remember that death is not the end, but only a transition.
You know, sometimes when you do this kind of stuff, it's hard. You hit roadblocks, you want to give up, you want to hang your head and say no more. It's the perseverance. It's the belief that you're going to be able to do it is what pushes you to the next level. This was one of the hardest weeks of my life trying to get this thing done. Not because it was a hard task, it's because I had to understand something new and cram about 6 months worth of knowledge into about a week's worth of work. This time, I won. And the joy is just outstanding. Take a look. Hello, everyone. I'm the old man, and right now we're looking at some cool stuff. I did the ZVS, and here we go. Mike Dodds is with us, and Benefactor's with us here today, and we're going to rock this thing out with some Tesla coils, guys.
What's going on, everybody?
Benny, I love your stuff, man. Your face doesn't move, but you sure do talk, man.
It's frozen again. I need to get a proper camera. I'm going to get one this week, I promise.
Oh, it cracks me up every time, brother. Cracks me up. Right on. So let's see. What do you guys got? You guys got some Tesla coils to check out today or what? Anybody?
Froze freezing out there.
Oh, man, you're breaking up. All right, guys, I'll start it off. Look, I've been working on 2 Tesla coils here. I got one over my shoulder right here on this side. If I can point my thumb the right way. And then one right behind me right here. That one right there, we're going to take a look at today. I'm going to fire it up during the live show. Man, it sets off some sparks. That's the one you saw in the intro video. It's going to be really awesome, man. So I'll turn out the lights and we'll hit it. But it's going to be a really good show, guys. I love Tesla coils. And then I know Benefactor says he's got a Tesla coil and he's got some cool stuff with it. Is that up and going today?
Yeah, I could set that up real fast. I got a small little blue Tesla coil I got from Amazon and some Noble gas tubes.
Oh, dude, I love gas tubes. All right, that's cool, man. All right, Mike, you back in? You good?
Yep. Sorry about that.
All right. So, guys, how many Tesla coils have you guys built? You guys built any?
I tried to get a kit.
No.
No, I tried to get a kit off Amazon, and I think it was a cheap kit. And when I put it together, it didn't work. So I'm gonna get another kit, but I haven't successfully built one yet.
Oh, well, that's not good.
It's on my list to build one.
It is?
Yeah.
You guys working on
Never
the
got into
Houdini
that.
circuits?
Yeah, mostly.
Yeah, we got
pulse
too
motors.
much on the plate, but definitely want to build one at some point for sure. And your tutorials will be key in that.
Oh, yeah. Well, the cool thing is when we looked at the Java on the Tesla coil thing, we set it up so that you can evaluate your numbers and know exactly how big to build this thing and exactly how long it has to be to resonate in the proper area. Because the ZVS circuit is real particular. It only goes like between like 400 and 250. That's where the signal can be picked up at. So your coil just has to be in that range. If it's in
Right.
that range, you're good to go.
So it's like when Tesla originally devised his Tesla coil design, he weighed out the material ahead of time. You know, he weighed out the exact material for the coils that he was building. He built them out of the same block of material. He melted down a block and weighed it out exactly. So that's how he tuned it, I guess, and that's what we got to do here, right? We got to design it to spec.
Yeah, it's inductance value. So the amount that goes into it is how much inductance it has. So when you want to resonate it, you have to take that into account. And if he knows the value of his number 2 coil, he can do it. The problem is when you start attaching things to that, it all changes.
Yeah, inductance grows with every piece of copper you attach to it or whatever metal.
I attach my gravity flyer and 360 kilovolts is what this thing picked up. That's how much inductance more that it takes. It's 3 pounds of metal. I mean,
Yeah. Like we've seen inductance systems. They actually do produce more energy. We're just not utilizing it correctly. Like the back EMF, we're not tuning the coil to work with the system correctly. So we're wasting like what you said, 80% of that energy.
As a matter of fact, they tune it out. They
Yeah.
stop it from being in the system. That's the first thing that they do, is they weed all that out. And what happens is you're left with a system that's maybe 30, 40, 50% inefficient.
Right.
Right. That's with like most devices, but the DC motors are becoming close to 100% efficient because, they're permanent magnets and DC pulses, and there's no and they are utilizing the flyback in these new motors. I'm sure of it.
Interesting.
Otherwise, how
no,
are they
it's
going
just
to
a
get
matter
that
of
high?
time. It's just a matter of time. They're probably not telling anybody.
Yeah, they don't have to announce it, but they're getting close to 100%. They're at 95% already.
Wow. Yeah, they have to be
DC
utilizing
motors.
the back EMF somehow then.
Exactly. That's what I'm thinking. And they don't use transistors. They use these, intricate commutators, with a lot of,
Oh, the integrated
switches.
circuits?
Commutating, intricate and complex commutating.
What's the
Like,
difference?
Well, let's say you got axial pulse, DC pulse system where it's around the, the radial, where you got coils around the radius of the rotor. But you don't want to necessarily pulse them all at once. You want to pulse.
Right, they have to be in a pattern.
180 apart, and you stagger two, and you go like that. Pulse, 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 pulse. That's how you get that maximum, force on the whole turn, and there's no loss of force, I guess. And
right, because you're utilizing it. It's like the natural wave of the energy you're creating. You're utilizing it, and you're kind of fitting into it in exact
right,
the right way
but to
pick it up.
pulse at like, let's say 360 and 0 degrees there, and then the next, let's say you have 4 switches being handled by one turn on a commutator. So that's how these DC motors get to high efficiency.
There we go. Okay, yeah, sorry, I lost you for a minute. I think it's my internet. We just froze for a second.
Nathan's coming in and out. He's jumping in and out of the matrix.
I think a lot of this has to, goes back to, the field geometry that you're creating in the system. It has to complement the pickups correctly.
Right. So if you got a rotor with 4 magnets, 2 and 2, around it, 2 and 2, then you got 4 coils, 2 and 2, and you would pulse these 2 and then these 2. But to do that with the switch, you can do that with transistors all day long, but the flyback's going to kill your motor in no time. So they make commutators that can handle this high voltage flyback because there's no integrated circuits here. It's just it's a real contact, It's a metal contact.
it's a physical contact, physical switch or whatever.
A commutator is just an advanced read switch with being able to do more than one read in one 360-degree turn, and being able to switch more than one device in 360 degrees. You can do that with a commutator. You can't do that with a read. Well, you can do that with more than one read positioned in different locations, or you can use one roller commutator with pins to make contact. Kind of like that musical box works with the thing. The roller and the point sticking out, it hits the metal pins to make the music.
So what we're basically talking about is one of the Bendini inventions, right? The big flywheel with the magnets on it.
Yeah, I think he used transistors though.
So he didn't use the commutator.
He probably had some commutators. I haven't seen it.
Hey guys, I'd love to talk about that, but let's light up a Tesla coil.
Yeah, let's get back on topic.
I got mine ready. Let's go ahead and light it up and see what it does. I got to take off my headset so I won't be able to hear anything, okay?
All right.
Here we go.
Hmm.
Did you guys see that?
Yeah.
That was
You
pretty
got it
cool.
stable.
Yeah,
Nice.
that was pretty. Yeah, it was pretty big. So, how are you getting it the spark to be that to get that big?
What it is
Sure.
using the ZVS, off the shelf ZVS. I just changed the capacitors and then got it going. Let me turn on my lights and I'll talk to you guys. Just give me a minute.
All right, we'll go back into the talk room for now.
Sorry about that. Let me straighten out my camera real quick.
It's all good. It's not like we got a crew helping us.
Nope, not today. So basically what it is, I just took a stock ZVS off the shelf. I saw a video on it, and a guy on my channel named Sean came on here and helped me out, man. Totally awesome guy. He stuck with me through all the hard times of this thing, man. And trust me, there were a lot. But yeah, what we did was we just got it humming and we checked out the, like I said, the Java. We got the number correct, right? So we got the resonance to happen. We knew the number we had to be within. Again, that number was anywhere between 250 and 400. And you had to build your coil specifically for that. So the coil that you just saw went off was resonating at about 320 kilohertz. So we're right in that range, right? Then it went through, and when we changed the capacitors out, just 2 caps, that's all we had to put in. We took out the 6 that were there. And then we got this thing going, man. Had to check it out, find the resonance signal. I printed out new bases for it, wrapped all the wires. You guys probably saw that video where I wrapped the red one, the one on this side. And then I did the other one. God, that wire is so small. I felt so old. It was just like I couldn't see it. I literally, dude, I took my wife's reading glasses so I can magnify and see this thing.
What gauge was it?
It was 32 gauge. And you have to line it up perfectly as it goes, no winding machines, all by hand. So anyway, it was just a big pain. But once you do that, you can get this thing rocking, man. And it took me a little while to click in. Sean was way better at this than I was. He saw all the Tesla coils on there. Those are all his. He's way ahead of me on the circuit, man. But thankfully brought me along with him so that we can get this thing really going, man. And you saw it. It rocks out, bro.
Yeah, that's the biggest spark gap I've ever seen.
So, yeah, we hit, what was it? I want to say it's like 8 inches on this thing is where I'm at right now. Mm-hmm. And it just hit the resonance point today, like an hour before the show. I had nothing. I had nothing, man. I wasn't there. I spent the whole week. I blew up 3 ZVSs.
Oh, wow.
Got to this one. They showed up at 7 o'clock this morning with a new one. And it was just stupid things on my part. I just put it in the wrong place. That was it. Just a wire out of place, blow up the whole thing. So
that's how it happens.
Yep. And once it got there this morning and I could see it there on my oscilloscope and I could see that it hit the perfect window, I said, okay, we're done. Don't touch it. Leave it against the wall. We're not doing anything. I'm just going to blast it. And thankfully, man, we hit this thing hard. So.
Yeah, usually when I see those big discharge Tesla coils, they have that big donut around the top. You're just like using a regular old small Tesla coil with a ZVS, right? And that's what's producing it, huh?
Dude, that's 4 inches, 4-inch pipe. I think it's small. Like these things are pretty monstrous, man. Uh, like the one behind me, you see it right here. This thing's probably
Oh, so
close to
that's
2 feet
it was
tall.
hard to. Oh, it's hard to gauge the size of it because of the distance of the camera. Okay, so it's about 2
Perspective.
feet tall.
Yeah, the other one's about 14 inches tall. And
That's the one that I thought you were using.
that's the one I was using right
Oh,
there.
that was
Yeah.
okay.
I didn't
But it
fire
still
up
has
the
a-
other one.
It still has a really big discharge for the size, though. You know, like usually
Well, capacitance doesn't matter if it's just the wire size. One has 28 gauge wire, which is the red one. This one has 32 gauge wire. So it's just a capacitance difference. It's going to come out with more windings on this one because of the wire gauge.
wow. Yeah, no, with that really thin wire, you just expecting it, not expecting it to be that. That's crazy.
Yeah. I tried 34, man, and it broke halfway through.
Oh, it
So-
like destroyed the wire.
Yeah, it just snapped 4 times,
wow.
snapped on me, and I just put up my hands and said, okay, we're going 32, man, until I can get a better winding machine that's not, fueled by me. I feel like a hamster in a wheel. I'm just churning and churning until it's done, man. It's a wild ride.
They
But,
can be tedious winding coils for sure, and that seems
Oh.
like it's even more extensive than a rodent coil.
Yeah, wait till you do it, man. Your hand's gonna feel all the arthritis in it. You know what I mean? And you're gonna hate life. You're gonna have to put tape on it every few minutes, man. Shake out your hands. Your eyeballs are gonna be popping out of your head because the wires are so small.
Yeah, but
It's
when
just-
you finish it, it's glorious. You know, like you're like yes.
Yeah. Trust me, that last inch is the hardest because you got to get 2 fingers in there. I got big fat fingers and they don't like to go in little spaces, so you have to get it in there and turn it like this. Man, a little motor, $30. I should have spent the money. I could have printed out the rest of the parts and
Right.
got this thing going.
Mhm.
It's just ridiculous, man. I should have spent the money, but I've been buying ZVSs like they're going out of stock, bro. This is crazy.
You can make a ZVS circuit too. Not
Well,
that hard.
that's the next step because we have
Yeah.
to expand the range. I got coils
Deeper.
that I want to run that, I need a higher value.
Yeah, you need something more custom made.
Yeah. So that'll be on the list, man. But this is just one. You got to get it running. This is the same circuit that's going in my Tesla coil for my gravity flyer. So it has to be right. And you can see it stands up to the abuse. I didn't blow anything up. It's still running. You know what I mean? I can fire it up again. It's not hot. So the CVS, it's taking all the power and shooting it out the top. So if you can't see, I got a Variac sitting right over here too. I'll show you. That's what it's connected to right there. And
Right.
it's just got 2 diodes on it just for you, Mike. So
And-
we
What?
we didn't rectify it all with a DC. It's still an AC signal. But you were talking to me before about the double hump. In instead of the 1, okay, on the top, and then it goes down to the bottom. It
Yeah.
now goes 1, 2, and then it keeps going like this. So
on your output of your Variac,
that's it, because I
Uh-huh.
put 2 diodes in there.
you wanted it to be DC or
It's now got a half AC bridge,
a halfway AC or whatever.
half wave AC. So
Yeah.
now,
It
like I
gives
said,
it gives
instead
you a
of one
halfway.
arch, we go
It's a halfway sawtooth kind of.
exactly.
So you're splitting up the waveform, half AC, half DC.
He's bringing the bottom half to the
Uh.
top. AC is like
Oh.
this, Ben. It's like this, So he's
Right.
bringing the bottom half up to the top. So now he has 2 tops.
Yeah, exactly.
That's cool.
I never knew
So-
I could do it until Sean told me. He told me, "Hey, do
Yeah.
this," and that's what we did, and that's what gives us the big sparks.
It gives you the
Wow.
pulsing AC.
Yep.
I'm sorry, a pulse DC.
A pulse DC.
Well-
so it's essentially a DC.
It's a
but
pulse
pulse.
DC. It's
Yeah. Wow, that's cool.
It's,
Yeah, so many
it's
things I
half of
didn't
the
even know
AC
were
signal.
possible.
Dude, there's some tricks to this thing I don't know. You know what I mean?
There's
Like
a
I said, this
circuit-
is my week into it.
There's
This
a
is why I
circuit-
need an oscilloscope.
There's a circuit called the poor man's desulfator. It does the same thing. It takes the AC signal on the bottom, brings it to the top, and gives you your pulse DC to charge batteries and desulfate and stuff.
I see impulse current.
Integrated
Fire in
circuit.
there says. Yeah. So, man, yeah, this thing is awesome. So, like I said, when I hook my other one, I'll show you this coil. When I use this number 2 coil right here, I have to put.
So you're driving the coil with DC now. DC. Okay.
I think it's still AC. So, anyway,
halfway AC. You're driving it with a
half bridge. So, when I hook my gravity flyer up, like I showed on one of the tests that I did on the Facebook group. When I hooked that up, like I said, 360 kilohertz is what it adds for inductance, minuses from it. So we're looking at 700 before. We took away about 360 from it. So it's right about 340 is what it's at. So it's perfect to go right in the ZVS system now. As long as the gravity flyer is hooked up, it now will resonate properly in there. And you saw the power I get here. Dude, I'm dying to put this thing on my gravity flyer. I just didn't have time today. Okay. It's, you know what I mean? Once you get it running, you're like, yeah, let's get in there. I don't care what this. It could blow the whole thing up, man. I may have to start over and I just don't care. Run, you're like, yeah. You know what I mean? I just want to see the power get into it for the first time. And I got a spare gravity flyer sitting over here, man. I can run that one in case something happens. But I'm just excited. So.
Oh, it's very exciting because isn't that the missing piece of the puzzle for your gravity flyer to get it to actually work is to get that to resonate at the proper frequency and to get the Tesla coil powerful enough, I guess.
Let's just put it this way. When magical things start to happen, my it just absolutely hated it. And it buzzed the number 1 coil. Just, you know what I mean? Awful. It was total feedback in it. And yeah, so I know this thing's pretty tough. So when I hit it next time, it's going to go hard. Benny, you back?
Yes, I am back. I don't know what's going on. My internet's keeps on taking a crap every once in a while. So I'm just going to be delicate with it today.
Okay. Yeah, the DC circuit, by the way, is easy to do on this. Naturally, it was set up with DC. So all you have to do is take your DC power source, whatever you have, and it'll do sparks at about 40 volts. So 60 volts is where I was running it right now. So what you want to do is hook in your DC power source. It works just like normal. You plug in the positive, negative, and then on the negative, what you want to do is put a switch in the middle of it so that you could turn it off and on the negative right there on that side. Positive just runs clean to your power supply, and it'll run DC just fine. You'll get more resonance out of it than you do sparks at that point. So you'll just get a higher field if you run it in DC, but not a problem at 60 volts. This thing's a beast, man. It'll go for a while. So I was messing with mine for about 2 hours on and off, and I didn't blow up the circuit. It was only till I crossed wires that I started blowing stuff up. So
you don't cross the streams.
Well, he's got a lot of patience too. Let me tell you that right now. You kind of need a lot of patience when sometimes dealing with me because my mind works so fast. It's like I got to slow down. You know what I mean? Like I'm thinking 3 or 4 steps ahead of you, and then I got to get back on your page to see it the way you're seeing it. You know what I mean?
For sure.
So.
Yeah. Communication it can be tricky, but I think we got a system that works, hopefully.
So, all right, we'll put up another one right here. So it says, running it on DC will provide a continuous wave breakout. Running it on AC with diodes provides a large lightning output. Yeah, just like I said, it gives you the radiant, of energy. If you have it on DC and you want the sparks, you go to AC. So, right there.
Got a lot of great questions.
You mean if you want the amps, you give it AC.
Yeah. And Sean could probably tell you, Sean, if you could, you know what the amps are going in on this circuit? Maybe you could just let us know. So he's got.
Well, what's the coil resistance? The Tesla coil. What's the resistance on it and the voltage you're giving it?
Oh, dude, I was giving it 60 volts right there when you
And
saw it going.
What's the ohms on the coil?
Oh, I don't know. I didn't check.
What
It
do you
never
think it
came
is?
up.
What's the gauge on it?
It's 32 gauge.
About how many feet you say?
Oh God, it has 900 and something turns on a 4-inch pipe, so it's got to be over 1,000 feet.
1,000 feet. That's like a couple hundred ohms, 500 ohms around there. I'm thinking.
There you go. 7 amps from AC Variac.
That's 60 volts.
And 5 amps from a DC input. Sean built a cool bench power supply that he has. It gives him 24 amps on this thing, man.
Wow.
So he's going to be able to run whatever he wants, man. It's kind of jealous. I'm going to have to buy the same thing he did and put it together. But yeah, pretty
That's
cool,
pretty
dude.
impressive.
So yeah, I'm pretty happy, man. It finally all worked.
Well, it's great when we see like breakthroughs in projects like this. You know, like we all have our hiccups and our hitches where we just can't figure out how to proceed, and then it's so refreshing when you finally see somebody like you is like, yes, I finally figured out what I need to do, and this is my game plan from now on, and we actually have a route to our goal.
Yeah. Trust me, it wouldn't happen without him. So this thing was tricky me. All the videos you can watch. So what we're going to do is in the future here, Sean and I are going to get together and we're just going to make an instructional video. You got to do this, put it in Java this way so that it can tell you exactly how long the thing has to be, what to cut the pipe at, what to cut the wire at, what's the numbers you should be reaching when you do wind it so that you can make sure you're in tune with it. And at that point, I'll give you the ohms right there in that list and just everything, how to test it. That way, it's a simple thing. Look, we'll put about, 6 coils in there on what we could build. I got 2 built. We'll get 6 going. Once we have those, anybody will be able to buy it off the shelf, have this thing running as long as they build the coil within like a week, man. You know what I mean? And that's what time with winding it by hand. You got a motor to wind it or you buy a coil already, by all means, you'll have it done in a couple days.
Yeah, that makes a difference with having something to help you spin it.
Yeah.
Might be a good business to make Tesla coils,
Hey, man, I'm retired, brother.
No, I mean, you get like a motor set up, make it automated, and you know.
We can still print rodent coil frames, man. Custom made ones. That's a viable business right there.
There's
They're
all
so
kinds
hard
of,
to make,
Not really. Those things are somebody already did all the work on the STLs. We can size them to anything you want.
Pretty much.
You know what I mean? So
we just can't we just can't infringe on anybody else's who has like a patent or anything. But like I know Jordan from Alchemical Science has a nested frame that he does not want monetized. But other than that, like there's tons of frame designs and we can even tweak our own. Like I was thinking about working with a graphic designer and trying to recreate the advanced 3.0 vortex coil. It has very thin openings for the coils, the coil wires to set in. So it's a little bit different than the frames we see, where it's a thick V or a thick opening for a bundle of wire to set in. It's just a little thin V-shaped opening for the slots. So
you're asking for it.
Down. Yeah, but it's going to be tricky, but I think it's possible to recreate that.
Yeah, you're asking for it, man. Those things, I don't know. As long as the outside doesn't hook in, I guess you're okay. But as soon as they start doing that, you start chipping wires. It starts really.
Yeah, and the smaller ones are very hard to do. Like the advanced 3.0 is supposed to be a lot smaller and compact. So winding it's going to be a bee. It's going to be a pain in the bee.
Yeah, I don't know, man. That's all you, brother. My hands can't tolerate that.
It's okay. It's something I have planned for the future, but I definitely want to get it done because we don't see any of those coil frames anymore, and I'd like to get them available again, you know?
Yeah, that'd be cool. Take some time to design it.
Yeah.
Yeah, I've been backed up on everything, man. I have had 100% focus on these Tesla coils, that's for sure.
Yeah,
No.
because... And what's your, like, are you planning to integrate that anytime soon to the gravity flyer system? Like, are you planning on doing any testing this weekend, maybe?
Yeah, this week, all week.
All week, okay.
Yeah, it's like this thing's up and running. I'm gonna order 4 or 5 more ZVS circuits because I'm gonna trash some. Let's just be honest. You know, I'm gonna hit this thing with everything it'll take just to see what it does. Then we'll tone it back to where I need it. So,
and how long have you been working on the gravity flyer?
Dude, I've had this thing for like several years, and in the last 5 months is the time I focused on it.
Yeah. Like okay. So about 5 months you've been working on, and we're like, ladies and gentlemen who have just been introduced to this this gravity flyer topic. We are or Nathan is on the precipice of solving this thing. Like he has never been closer to actually getting this to lift off the ground. And this is the missing piece of his puzzle, and I'm so excited to see what it's actually going to do. You know, when you actually get this Tesla coil working with the gravity flyer,
it's going to do something awesome. Trust me, it's right there. You know
so
what I mean?
The Tesla coil is like putting like a radio signal connecting to the flyer, right?
Well, think of it this way: if it's adding capacitance to it, right, and your Tesla coil is a capacitor to ground, okay. I'm now completing the circuit to ground when this thing is on the ground. So the energy's flowing and it's flowing hard. So I'm pulling it from the earth itself into this thing, and it's coming in as charge. And it's not coming in as, voltage per se. So there's voltage coming in the top, but the charge is coming up and it's filling up the bubble that it's in. So it's conversion. So you guys saw my video on when I wound the coil, right? Mm-hmm. And how I got the resonance frequency in the winding coil or the spool wire. It's exactly the same thing. That's exactly what I'm doing. I'm converting that charge that I put in that PVC pipe into the gravity flyer. And it's just hits it once and it creates a burst of energy. It's
like you said in one of your videos. It's more about the process and less about the parts that you're using. And once you find that process and be able to fine tune it, you can pretty much manipulate the gravity flyer however you want.
Yeah, it's totally different, man. You have to.
So, are you kind of comparing the flyer to like a capacitor plate?
It's
the middle plate, isn't it?
It's sucking everything in like a capacitor. But it doesn't have the limit that your capacitor does. The field keeps growing. That's the thing. Because you got to remember this. You have the Tesla coil field here. You have high voltage on the inside of the field. As the high voltage grows, it can push that Tesla coil field a little bit out. You know what I mean?
It's kind of like a capacitor that's not contained.
That's right. So
the flyer is not contained by an insulator. That's why it keeps growing. Maybe the air is taking. I'm
converting the air.
The air is becoming part of the flyer and its capacitance. It's growing into the air. The capacitance from the flyer, because if it were contained, it wouldn't be able to go out into the air and build capacitance with the air also.
Yeah. So 2 things you have to do. You have to create a gravity well, and you have to be able to convert the air. And when you build the bubbles on this thing,
or the atmosphere,
you have to be able to convert that air inside the charge. And it creates, by the way he designed it, it creates its own gravity well. Okay, it's pulling in, it's also pushing out with the 2 different fields going on. Then on the inside, it gets charged. So you're removing yourself with that resonance from the actual, earth itself. You're pulling yourself out of that field, and you're
Oh, so
creating
you're
a field around it.
isolating yourself from the magnetosphere. Oh.
Right. So everything flows around it. It's like
Oh,
snow.
that makes
Snow
sense.
comes
That's
down
a good
as
picture.
it
Okay.
as it
Yes,
rocks.
he's oscillating.
goes
You're
around it.
oscillating. You're oscillating at a different frequency than the Earth.
Huh.
Yeah.
300
No,
and some
there-
kilohertz, right?
I'm not allowing it to push down on it. I'm not allowing things to build up energy on it. So it's not allowing it to push down on it. That's the key.
There was a live stream that Bob Grenier was doing earlier today, and he might be still streaming, but there was a part he was talking about the reversed alien replication vehicle and how it relates to the fractal toroidal moment. And if we have time, I'd like to show you just a small clip from it, because he was talking about, you know, the process he thinks these things lifted, and it had to do with a lot of similar subjects and topics we're talking about here. And the alien replication vehicle, I think, was split up into like 48 parts, and that number was very specific for a reason. And I don't know if you're interested, I'll find the clip and I'll play it in a little bit.
Yeah, if you can pull it up, by all means, do it. I always love clips of different cool stuff, man. So I actually have a clip here in a little bit, man. I gotta find it though. So you know, if you guys could do this for a minute, I'll look for it real quick.
Yeah,
I'll pull my
I'll
stuff out.
pull up, because I got the Martin Fleischmann Memorial Project video right here. Just need to find it in the video.
Where is Bob?
Oh, Ben, we got to do something about your camera, buddy.
Announce that we've officially opened the
It
library.
looks like Max got the Max Headroom effect.